Good day, everyone. Thank you for coming today. I'm really honored to make a presentation about CTR technology for you. This is James speaking. I'm in charge of CTR PE team. PE means product engineering. As you know, CTR has been supplying ball joint, auto tie rod, inner tie rod, stabilizer ring to almost all global oil automakers for a long time. That means CTR ball joint and all parts are installed in vehicle almost everywhere in the world. In other words, we are familiar with what the extreme environment conditions are around the world. Based on that, I like to share our engineering information and knowledge with you here. Before we dive in, let me share a bit about my career. Prior to this role, I spent 10 years as a senior engineer in oil division. I also had the privilege of working as a guest engineer in global oil automaker lab in China, where I focused on suspension development. Along the way, I helped design and develop the steering and suspension parts for many oil car maker brands. Here is a summary of main topics as follows. First, I will tell you about the CTR AM R&D development capability. Second, I will share CTR AM product features and know-how. And I will share results to compare with competitor products. Are you ready to begin? Then let's start the first tech seminar in Oman. First is CTR AM R&D development capability. CTR starting with research activities and CTR R&D Center since 1990. We have achieved some important technology development. And since the establishment of the R&D Center for Aftermarket in 2015, we have been training specialized professional for the aftermarket. In the aftermarket R&D Center, process research expertise, proven technology, advanced research tool, test lab, and material development capability. In the aftermarket, CTR stands alone as the world's sole company with such R&D capability and advanced technology. Now let's discuss how CTR develop in products. Basically, our development process aligns with OE principle, which means that we are prioritizing focusing affordability, quality, and reliable delivery. In the kickoff stage, we are carefully plan our development schedule, conduct VIOC analysis, and extend this approach from design and testing to production and sales. Moving on the design path, in this stage we select material that suit vehicle and road condition. Fine-tune dimension using the 3D modeling and FA analysis. In the analysis path, we perform the cost analysis after design completion and ensure design specification align with the POEM criteria through the testing. For the fabrication, production lead time as a ball joint 110 days, auto tie rod 100 days, inner tie rod 70 days, and stabilizer ring 70 days. When it comes to unloading path, we input the output into the system once production achieved are finished, including APQP output, new item list, catalog, and illustrator. Our professional and detailed development process proves why CTR products are trusted by our global customers. Now, let's take a look at how we design our product. Unlike our competitor, we don't just copy genuine parts. We review static and fatigue load case, test specification, operation angles, target mass, and package interface. Following this, we carefully select ball bearing materials and ball size based on the allowed surface pressure calculation. We then set fixed material and dimension for all components. To ensure confidence in our choice, we conduct FA calculation analysis. If the result meets our standard, we finalize freeze the design. If any aspect falls short, we revisit and make a necessary adjustment. The next topic is CTR unique technical standard that span over half a century. We store all of our analysis standard, material standard, design standard, and test standard in a digital archive. This digital archive is known as a PLN system, where all records are carefully organized, managed, and fortified with robust security features. Second content is CTR product feature and know-how. In 1886, Carl Benz from Germany invented the first automobile powered by gasoline internal combustion engine. Carl Benz automobile is considered a precursor to modern car. From the 1820s, cars with a version began to be made gradually to meet the demand of consumers seeking more convenience. In the 1840s, when versions started to be commercialized, they were developed with the specification that required grease injection. These products did not consider ride comfort or vibration at all because they contained a steel seat inside the ball joint. At the time, cars were made solely of steel without using any aluminum plastic. With the advancement of plastic injection technology, it became possible to mold a desired shape. As a result, plastic seats were applied inside the ball joint, enhancing torque, vibration, and durability, which allowed for the removal of grease nipple. Currently, CTR has applied the latest technology specification and material to ball seat in ball joint. Today, we will reveal all the difference between CTR products and those of our competitor. The material used for all the components in the production of our ball joint and outer tie rods are identical to those used in OE products, and our design expertise is also the same. The ball stud, boot, ball seat, socket, plug, and grease are all made from the same material as those used by the OE division. CTR uses the cold forming method to produce the housing of inner tie rods. Generally, aftermarket suppliers apply the hot forming method or simply add heat treatment to roundabout materials to reduce production cost. However, CTR produces the inner tie rod housing using the cold forming method because it is critical to drive safety and direct impact product quality. If the thread of the housing breaks, it can lead to loss of control of the vehicle. Additionally, CTR designs its product identically to OEM parts to ensure easy assembly with the counterpart component. CTR offers four excellent types of stabilizer ring: A and B type, price competitive with superior performance; C type, suitable for SUV or large vehicle; hybrid type, specialized for luxury sedan with excellent durability; U type, scheduled for release at the end of year, offering price competitiveness similar to A and B types with the superior strength. All steering and suspension products from the CTR use the specialized grease developed exclusively by CTR for automotive ball joint. CTR grease is the same as the grease supplied to global automaker and is protected by a development patent. Here is an interesting video evaluation of CTR grease Shall we enjoy it together? CTR production philosophy is zero defect. We share our production system and experience with the OE division to provide our customer with the highest quality product. Our production process is divided into the three key themes. First, component loading. All components undergo rigorous measurement and vision inspection before proceeding to assembly stage. Second, sub-assembly and cooking. This crucial stage determines the installation, accuracy, and performance of the product. Finally, boot assembly and package. The production is finalized with the boot assembly and then carefully packaged in a dedicated box. To ensure that we deliver product our customer can trust, we have automated most our process and include a 100% inspection process to prevent any defective product from reaching the market. Is this level of technology common? The video we are about to show that demonstrate the standard of some companies you may have encountered or might encounter in the future. We ask for your understanding as we cannot disclose the name of a company in the video. Now let's watch the video CTR assembly process and technology level. Please observe the difference. Finally, we reach the last part. This content is comparison between CTR and competitor. This page summarizes the test result of ball joint from CTR and competitor, A company and B company. CTR used the same ball size, operation angle, and surface coating as OEM product. However, the competitor products have smaller ball size or coating that do not provide rust prevention. Additionally, CTR ball joint excel in pull-out and push-on strength. Even after wear endurance test, CTR ball joint show minimum play change, whereas competitor product exhibit significant play change, rendering the ball joint unable to perform their function. The function of a ball joint boot is to protect the ball joint from dirt, particle, and moisture, ensuring the longevity and proper operation of a ball joint by maintaining lubrication and prevent contamination in the initial state of the product. We do not anticipate any issue with the boot. However, once it is assembled with knuckle, the following issue may arise. The boot of A company and B company product were assembled abnormally. Simply put, they were twisted during the assembly. In contrast, CTR boots are compressed and assembled very stably. What would the result be if we conduct an environment wear driving test on these assembled state? The test would be as shown in photos. A company and B company products are tear around water and mud to penetrate inside, leading the loss of functionality and potential separation of bolster. However, CTR products show no tear, no slip. The competitor boot lack technical know-how and appear not to have undergone boot FA. The following table shows example of parallel mode in competitor products boot. Observed defects include abnormal port, excessive port, self-contact, twist, high and low temperature aging, and wear deformation. To ensure the quality of our boots, CTR undergoes 4 strict verification process. First, boot FA. We used this analysis to predict and address potential issues such as excessive fold, twist, gap, and self-contact, pioneering designed accordingly. Second, boot durability test. Once the product is completed, we conduct a durability test to confirm the boot's long-term performance under various conditions. Third, high pressure leakage test. To ensure the boot can withstand the water pressure from the high pressure hose used during the car washing, we perform the high pressure leakage test. Fourth, sealing ability, seal twisting, and low temperature oscillation test. These additional tests verify the boot's durability and performance, ensuring that it meets the highest standard of quality. By implementing these comprehensive testing, CTR guarantees the superior quality and reliability of our boot. Not only those we take various tests, only the boot that pass all tests can be used when we develop the item. The surface treatment of a ball joint play a crucial role in ensuring its performance and longevity. Here are the key functions of a surface treatment. First, corrosion resistance. Second, wear resistance. Third, improved lubrication. Fourth, enhanced strength. 5. Aesthetic appeal. This test is a corrosion resistance test. It compresses the natural condition experience over 10 years into an accelerated evaluation. The test was conducted using the equipment and methods required by automotive customer. The test results show that all competitor products exhibit rust after 48 hours. However, CTR products show no sign of rust up to 240 hours. Have you ever seen product with the same packaging and brand logo as CTR, but with a strangely low price and somehow reduced performance or functionality? In the past, there were businesses copying the CTR brand. However, recently many countries have seen products that copy not only the packaging but also exact design of CTR product being distributed in market. Some customers knowingly use these fake products. The following material will explain the danger of using the fake product. This test is a well-derived test for ball joint. The purpose of this test is to determine how long ball joint can withstand the actual driving condition and to show its performance and quality after the driving test. The test conditions are based on the ball joint wear durability test standard. Axial and radial loads of plus minus 0.63 kN and plus minus 4.55 kN are applied. The load application speed is 8.3 Hz and total number of load application is repeated 1 million times. During the load application, the bolster rotates plus minus 28 degree and oscillating plus minus 50 degree. For better understanding, please refer to video material, which will help you comprehend the wear-derived test more easily. After the wear-derived test, it was observed that the fake product developed a gap due to wear and deformation of the ball seat. However, CTR products show no sign of wear on the ball seat. In the spring travel test result, it was observed that fake product deformed approximately twice as much as CTR product. The wear-derived test evaluates the product durability, while the fatigue test is critical evaluation directly relate to the product lifespan and safety. The load applied in the test correspond to the particular life load for specific vehicle model, and required cycles are 10,000 cycles. In the test result, the pack products bolstered fracture at 2,276 cycles, whereas the CTR products bolstered fracture at 29,405 cycles. This demonstrates that CTR products have more than 10 times the particular lifespan compared to the packer products. Now, let me explain the reason for this significant difference. We analyze specimen after the particle test. The packer products show perite and perite structure, indicating absence of quenching and tempering heat treatment. In contrast, the CTR product exhibit more tensile structure, which is present due to proper QT heat treatment. Martin structure is superior in particular life and strength, and it is a mandatory requirement by all automotive customers worldwide. The hardness of metal is one of crucial indicators for evaluating mechanical property of metallic materials. Hardness refers to the metal ability to resist localized deformation under applied load. Metal with higher hardness typically exhibit greater particle strength, as they possess superior resistance to localized deformation. However, excessively high hardness can increase the brittleness of the metallic core, potentially reduce particle life. Therefore, it is essential to establish up to lower hardness limit. CTR hardness management standard is set between 26 to 37 HRC, aligning with the global automotive requirement. While the hardness measurement of the pack product falls short of the specified range, CTR products continues to meet this uniform hardness value. The summary of material analysis result for CTR and pack product is as follows. The pack products bolstered leg heat treatment. The pack product socket also leg heat treatment. Additionally, the boot and bolted grease used in the pack products are industrial grade. There are also significant differences in the exterior appearance of ball joint. The E-1 dimension refers to the bolstered taper angle, which is crucial as it affects the assembly with the mating knuckle. CTR bolstered has the same taper angle as the original equipment manufactured OEM parts. However, the pack project's bolstered has a different taper angle compared to the OEM parts. When a pack ball joint is assembled, it causes the tire to wobble severely as shown in the video. During the driving, the play between the ball joint and knuckle leads to partial failure of a ball joint stud, resulting in the loss of steering control and potentially causing accident, as depicted in the video. What do you think? Fake products are cheaper than CTR products, but are they worth more than safety of you and your family? CTR prioritizes customer safety above all else. I have a pleasure of present CTR technology. I hope this tech seminar has convinced you to choose CTR for your future automotive needs. If you have any question about the CTR products, please feel free to contact me. Thank you very much. See you soon.